all week, we've been talking about 5-number summaries, how we can use technology to find a 5-number summary, how we use that 5-number summary to create a box and whisker plot, and then we learned how to interpret box and whisker plots using shape, center, and spread. We had a formative assessment yesterday in the form of an E-class quiz, and I wanted to go over some of the details this week in a little bit more detail and show you what the shape, center, and spread look like on other representations, more so than just a box plot. So we're going to start off with a little warm-up, going over some of the stuff from last week. Here we have a data set with the ages of 10 people. It's asking us to find the mean, median, and mode. So why don't you pause the video now and go ahead and try and do that yourself. Well, we know that the mean is the sum of values divided by the number of values. So as you can see here, I've added up all of our values, all 10 of our data values, and divided it by 10 because there were 10 values in total. 80 divided by 10 is 8, so our mean is 8. Next, we have the median. In order to find the median, we can either use technology or we can order our list from least to greatest. In this case, it already was. Once we've ordered it from least to greatest, cross one off on each side. We're left with 6 and 7. Whenever we have two numbers in our median, we take the average of them. So we add them together, 6 plus 7 equals 13, and we divide by 2 because there are two numbers there, 1 6 and 1 7. So our median would be 6.5. Lastly, we have our mode. Remember, the mode is the number that occurs most frequently. So if we look at our data set, we have 2 4s, 3 6s, 2 7s, 1 8, 1 15, and 1 17. So we have the most 6s. So our mode would be 6. Now we're going to start by talking about distributions. Again, guys, distributions refer to a group of data presented on a graph. The graph shows us the distribution. It's a visual representation of how the data is laid out. So we're going to be looking at dot plots today in addition to box and whisker plots and histograms. Let's take a moment and look at this histogram. If you trace this histogram, it seems like it's skewed right because most of our data is heavier on the left. So skewed right and left is the same for box and whisker plots as it is for histograms, dot plots, etc. If we looked at this one and we traced over its distribution, it looks like it's heavier on the right. So this one would be skewed left. So let's look at our first activity for today. It says we will be making a box plot. Use the information from the intro to make a box plot below. So right here at the top, guys, I've included the steps for creating a box plot. First, you find the 5-number summary. You can do that by hand or you can use technology. I made a video earlier this week showing you how to use Desmos. If you're going to use Desmos, you'll follow these steps here. You'll type L bracket, put your list separated by commas, and then go to function, stat, and type in the L in parentheses so that it knows I want the 5-number breakdown of the list that we named L. Next, you mark each number, the min, the Q1, the median, the upper quartile, or the Q3, and the max on your number line. Then we connect the minimum in the first quartile with a whisker. And we do the same thing for the third quartile and the max. We connect them with a whisker. And then we make a box stretching from Q1 to Q3. The median will cut that box into 2 pieces. You pause the video, load up Desmos, and try and find your 5-number summary yourself. Upon entering my data into Desmos, I got the 5-number summary as follows. I got a minimum of 4. I got a maximum of 17, a Q1 of 6, a median of 6.5, so that'd be in between 6 and 7, a Q3 of 8, connect Q3, and max, connect minimum in Q1, and connect Q1 and Q3 to create a box. So let's see if that looks like the keys answer. Mine does look like the keys answer. As you can see, each point is represented. We got 4, 6, 6.5, 8. Once we have the graph of a distribution, we often want to describe it. We generally describe distribution by commenting on its shape, center, and spread. Shape. To describe the shape, we generally use symmetric, skewed left, or skewed right. Here's symmetric looks like on a dot plot. Here's what skewed right looks like on a dot plot. And here's what skewed left looks like on a dot plot. So let's describe the shape of our box plot. Our box plot seems to be heavier on the left, like the skewed right example. So I'm going to say our box plot is skewed right. Next, we have the spread. To describe spread, we calculate the interquartile range, or the range, as we talked about earlier this week. The range is the difference between the largest and smallest data in a value set. Let's jump to right here. Range, maximum minus minimum. What was our maximum value again? 17, and our minimum was 4. So 17 minus 4 equals 13. So in this data set, the range would be 13. Next, we have the interquartile range. We also use that to describe spread. The interquartile range is Q3 minus Q1. In this data set, our Q3 is 8 and our Q1 is 6. So IQR for our data set equals 8 minus 6. So our interquartile range is 2. And lastly, guys, there is center. To describe center, we calculate the mean, median, or mode, although we rarely use the mode. If a distribution is symmetric, we use the mean. If it is skewed, we use the median. We talked about that earlier this week as well. It's important to know which measure of center you should be using to describe your data. Next, we have our second example. So a local fishing club has 13 members. Their average number of fish caught per trip were as follows. And there is a data set. So here I've created a box plot using our data set. It's already ordered from least to greatest, so I was able to see that 3 is my min, 25 is my maximum. I then used technology to calculate my 5-number summary. I found that my Q1 was 12, my median was 18, and my Q3 was 21.5. Describe the shape of this distribution. Well, it looks like the whisker coming off the left of my box is a lot longer than the right, and my box itself seems to be leaning to the right. So I'm going to say that this is left skewed. Yes, it was skewed left. Find the mean of the data set. Compare the mean and median. Well, we know our median is 18 because a box and whisker plot gives us our 5-number summary, including the median. So how could we find the mode? Well, we'd have to add up all of our scores and then divide by 13 because we have 13 scores. So pause the video now and go ahead and type that in your calculator and find a mean. That's right, we should have gotten 16.4 for our mean. And guys, remember in your calculator, if you see an X with the line on top, that means mean. Okay, guys? So is 16.4 larger or smaller than our median of 18? It is less than our median of 18. So what conclusions can we make about the shape of our data and the center of our data? Well, if it's a symmetric example, like we said earlier, it's more appropriate to use the median, because the median in a symmetric example should be about equal to the mean. In a skewed right example, the mean is often greater than the median. And in a skewed left example, the mean is often less than the median. Because the mean and the median do not align, that's why we often use mean when talking about skewed examples. Next, I wanted to introduce something a little bit more in depth that we've already talked about. So here's an introduction to normal distributions. So guys, a normal curve is a smooth curve that is symmetric. That means the same on one half as the other. They got the same halves. They're often bell-shaped or mound-shaped on a histogram, like the example to the right. Data distributions that are mound-shaped are often called normal distributions. One example of a distribution that is approximately normal is the distribution to the right. If we draw a smooth curve on top, like I've already done, then it's easier to see how if we cut it in half right here, it would be symmetric on both sides. And the overall shape kind of looks like the Liberty Bell. That's why we call it a bell curve. Besides bell curves, data can look multiple different ways. So for example, an A, that looks like a bell curve. If we were to put a line above it, it looks like a bell curve. It's pretty normally distributed. This example, while it is still bell-shaped, it doesn't look symmetrical. It looks a little bit skewed right to me since it's heavier on the left. And that's right, it's a little skewed right. Now this is something new, guys, of a new shape. That's not a bell curve. In fact, almost every bar is equal to the one before and after it. This data set is what we call uniform. Right? So it's neither skewed or normal. It's pretty uniform. We'll talk more about that here in a second. And our last example here, while the data points may not stretch as high as our other examples, it is symmetrical and creates a normal curve. Alright guys, so this last page is just to kind of help with your practice. It has a lot of information about what it looks like to be a normal curve or skewed in each of our different representations that we've looked at. So histograms. A symmetrical bell-shaped histogram looks like this. It's symmetrical because we can divide it in half and it's the same on both sides. Here's what that looks like on a dot plot. And we've talked a lot about what that looks like on a box plot this week. The whiskers are about the same length. Each half of the box is about the same. Next, we have symmetric U-shaped. Instead of calling this U-shaped, I like to call this bimodal. What does bimodal mean, Mr. Meyer? Bimodal means that it has two peaks, right? So we see one peak here, we see two peaks here. So it would be bimodal. But if we cut it in half, it is still symmetrical. But it is not normally distributed because it does not make the bell shape. Same thing goes for a dot plot. We can have a bimodal symmetric dot plot. That's what you see here. If we divide it in half, it is still symmetric, but it has two peaks. So it's bimodal. Guys, the box plot doesn't change. There's no such thing as a bimodal box plot. Box plots don't show us peaks. Then we have skewed left. Skewed left on a histogram, skewed left on a dot plot, and skewed left on a box plot. As you can see, all of them have the data weighing heavier on the right side of the graph. Vice versa for skewed right, the data is heavier on the left side. And then uniform. We just spoke a little bit about this, I told you we would talk more about it down here. So uniform data is when they are all roughly the same value, or they all occur at roughly the same frequency. We have just as many 10s as we do 20s, as we do 30s, as we do 40s, as we do 50s. The data is uniform. It creates a straight line. There's nothing more uniform than a straight line, right, guys?